Oh, I have been covering astronomy now for 40 years. And when I first came in, I thought that I was the cleanup operation, that I'd just be writing about all the details of all the things that they've already found out about. And over those 40 years, the mysteries of dark matter and dark energy evolved. We found out there was an accelerating universe. And when I wrote my first book, they were scrambling to find a brown dwarf, the smallest or known star or near star. Uh, and now they're finding even smaller things, thousands of exoplanets. That to me is amazing. That I never expected when I first started out in the 1980s that I would be seeing them discover exoplanets. I never thought that was going to happen in my lifetime. And also the new astronomy. I thought, oh, all of the areas of astronomy have now been opened up. What do I have to, what can I discover that the old science writers were seeing the development of radio astronomy and X-ray astronomy? And lo and behold, I had the great privilege of being at the foundation, the opening days when they were developing gravitational wave astronomy. I was first interviewing Ray Weiss, who got the Nobel Prize, and I first talked to him in around 1983, when it was just an idea in his head. And I remember thinking, I'm never going to see that. And lo and behold, I was able to actually be there while they were constructing it, interview all of the original people that were the founders of that enterprise, and wrote a whole book on the founding of this whole new way of learning about the universe in a way that we have never had before. This is far different from electromagnetic radiation. This is actually feeling gravitational waves going through the universe from the most powerful and active events possible, the collision of neutron stars, black holes. So that has also been a wonderful thrill for me over the course of my career. I don't know about discoveries because I thought they'd find dark matter by now. I was first writing on that. I was one of the first to write about dark matter in the early 1980s. Then it was called the missing mass, and they started calling it dark matter. I thought it'd be found by now, so I'm still waiting for the dark matter. But what I think is going to help, and what I'm most excited about, is now they have started this program they're calling messaging, in which all of the different arenas of astronomy are starting to coordinate with one another. That to me is the most exciting. They've already, by the cooperation between the gravitational wave astronomers who noticed two neutron stars. They got the signal of two neutron stars colliding. The X-ray telescopes and the optical and radio telescopes were able then to immediately look at the sky, find the event, and gather more information, proving that most of the gold in the universe is coming from the collision of neutron stars. My ring, this gold ring, was forged in the collision of a neutron star millions or billions of years ago, but now it's on my finger. That's, to me, the most amazing thing. And it's coming from this coordination from the various arenas, and I see that as one of the most exciting new ventures over the next decade. I think the biggest challenge is the current climate, political climate, intellectual climate, the attitude that the public now have towards science. I'm very frightened by that, because what science needs now more than ever is more funding in basic research. And I think right now the political climate isn't good for that sort of government support, such as the gravitational wave astronomy observatories. The gravitational wave astronomy observatories would never be built in this era. It just squeaked in when there was great support in Congress for exploring further Einstein's theories of general relativity. But I don't think that could happen today if they were trying to do that today. So I think the biggest challenge is going to get back that public support and political support so that basic research can continue. I was always interested in science ever since I was little. I was putting together atomic models at the age of 7. I really, really loved it, but I also loved writing. And so I had this interest in so many different things. And at first, when I went off to college, I thought, oh, I know what I can do. I can be a journalist and I can explore all these different areas of my interests. But then when I was a journalist for 4 years in my early 20s, I got most excited when I would go off and do the science stories. I was very near the NASA Langley Research Center in Southeast Virginia and writing about all their exciting projects, especially they were developing the Viking lander on Mars. I said, if I could do this 24/7, I'd be the happiest person in the world. I eventually started taking night courses in science, hoping that would help me in writing about science. And I got so caught up in it that I quit my job. I went to school full time and I ended up with a master's degree in physics. And after that, I put the two fields together. And starting around 1980, I started writing on physics and astronomy and astrophysics full time. What a journey. And I have never regretted that decision for anything. It has just been the most joyful, delightful career and such satisfaction to be able to meet the people who have made such findings and discoveries over these last 40 years. I thought at first I was quitting journalism altogether when I got caught up with the physics degree. But then I realized I actually started my PhD. But after a year, I knew that what I wanted to do more than ever was get back into writing. And while I was in graduate school, I heard there was this new magazine called Discover that was starting in New York City. And I, on a lark, just threw in an application to see what would happen. And lo and behold, they offered me a job. So I quit my PhD program, went to New York, never looked back. So I worked at Discover for a few years. Then I went freelance. I was a freelance writer for more than 20 years. But then I got an offer to start teaching, to start giving back. And what I learned as a science writer, to give back to my students in the MIT graduate program in science writing. And I've been doing that for 17 years. So I've had a wonderful arc. And no, I don't regret one bit of it. Well, there were those moments when you're on deadline and you're tearing your hair out and you're going, why am I doing this? But I always tell my students this. I love quoting Dorothy Parker. I love having written. It's when it's all done and you can look back at what you've done and you see that you have engaged and informed and educated the public who appreciate that they've learned something from your work, then it's all gravy. Oh, well, the first thing you have to learn if you really, truly love science writing, that your job is not to teach. It's one of the first weaknesses you notice when the students come in. They want to teach, especially if they have a background in science. It's like they want to give, Science 101 in their first 10 paragraphs. And the thing about science writing is look for the story, the human side, because science is part of society. And what you are trying to do is let the public know how science is one with the culture, not separate. And so you're looking for the stories and the explanation and the metaphors and the analogies that give them a feel for the science are done along the way, but it's all rooted in a good story. I always like to quote George Johnson, the New York Times science writer. He says, take the strange and make it familiar. And that's what the public needs. They're never going to learn. They're never going to read a newspaper article and take a pop quiz and know exactly, how to answer the questions on quantum mechanics or molecular biology. but you want to give them in their everyday language a feel for the mechanism in terminology that they understand. No, they're not going to be able to pass a test, but you are giving them a connection to that mechanism, that understanding, so that they feel that they're connected to that discovery or that finding in a way that they didn't think they could understand it. So relax. That's my advice to the scientists, is relax and find those metaphors and analogies, and don't think of your colleagues, think of your audience who is just dying to understand things like quantum chromodynamics. Carl Sagan did face great criticism because that's exactly what he was, doing, was trying to create that bridge to take the technical and make it more understandable. And he, it just wasn't an era yet where, finally he did get that recognition. And certainly, in astronomy today, Neil deGrasse Tyson is that translator. And I think the scientific community is now more comfortable with that because they see that it truly makes a difference if people can be reached and they feel that they are touching some of the great thoughts and the findings, the discoveries, the thoughts of the science community. I was just recently at the LIGO observatories down in Louisiana, and they have an education center. And there in the education center are all the scientists on TV monitors explaining the science in very engaging ways. So they themselves, when they go to LIGO to do their experiments, just across the field is an education center where they see that their fellow scientists are doing exactly that. They are educating the public. So they are now surrounded by it. They are getting more comfortable with it. And I think it's the best thing that's happened, actually. And I'm so glad that they put those requirements onto the grants, because it is the public funding it, and they deserve to hear what's happening. But they deserve to understand what's happening. So with the cooperation of people like me who are doing the translation and the scientists who are getting more engaged in that, hopefully we'll get a more engaged public.